All right, lesson 3. Why won't it? There we go. Lesson 3, graphing functions. This is going to be page 25, and I know I keep forgetting, but it is what it is. Page 25 in your binder. 3 functions are given in the table. Write down any initial observations about the functions. Leave space to add your observations. Add your observations later. Now we're just going to do the initial observation. So the one observation that they want you to notice is different between all 3 of them is going to be the exponent. Okay. Now, if you look at A, you'll notice it doesn't have an exponent. That would mean that your exponent is a 1. If it lets me write it, there it is. So that would mean that the input is raised. Remember, input will always be your x. It's the number that you're plugging in. Input is raised to the first power. Okay. You'll notice here on B, there is an exponent, and that exponent is 2. So the input is raised to the second power. And in C, it turns into something a little bit different. X becomes the power. The input variable is the exponent. The exponent is the power. How does this affect each one of these graphs? All 3 of these graphs are the types of graphs you're going to be seeing throughout this year. Okay. But the whole first semester, we're going to focus on all linear. The other 2 will be saved for next semester. Okay. So let's see what happens. Our equations right here for A, it's 2x. So that would be the rule. So what would you do is you take the x, or you take this number here, multiply it by 2. Okay, so we take 2, multiply it by whatever it wants us to input to put x in. I like to write it down first because then hopefully I don't mess up when I'm plugging numbers in. So first thing I want to do is plug in the number 2. 2 times negative 2, negative 4. The next number, negative 1. 2 times negative 1, negative 2. Next number is 0, so that gives us 0. 2 times 1 is 2. 2 times 2 is 2. So what kind of graph would this give us? Let's plot it. This is my x-axis. Always label. It's always good practice to label your x and your y-axis so you don't mess that up. Okay. So the first point is 2, negative 4. Remember, f of x is just another way to write your y. So your point is 2, negative 4, negative 1, negative 2, 0, 2, and so forth. So let's start with negative 2, negative 4. It's going to go where? Right here. Negative 1, negative 2, 0, 0. Did I mess up something? Oh, my negative 4 is way off. Negative 2, negative 4 is way down here. All right, there we go. 0, 0, 1, 2, and then 2, 2. Should not be 2, 2, 4. 2 times 2 is 4. Some of you are probably thinking it. Okay. So what is that? What kind of function does this give us? This gives us a straight line. Let's see what happens with the next one. With the next one, they want us to square the input. So take the number and square. So -2 times -2 is +4. -1 times -1 is +1. 0 times 0, 0. 1 times 1, 1. And then 2 times 2 is 4. How does this affect our function when we raise it to the second power? Let's see. -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. Now it kind of turned it into some kind of U shape. And this is one of the ones that we're going to see until the next semester. It is called a quadratic function also, and the shape is called a parabola. Parabola, okay? The next one is raised to that exponent. So 2 raised to the power of something, 2 raised to the power of something. And for that one, you might have to use calculator. So 2 raised to the power of -2. That's ugly, but it's okay. Sorry. 2. Now, when you're wanting to raise to a certain power other than 2, because I've already showed you, to square, you just put that, right? But when I want to raise it to another power, you're going to use that button that's right above division. And I'm sorry if you can hear outside noise. I'm on campus right now trying to record these videos, and I think they're vacuuming outside of the classroom. But anyway, so when you want to raise to a power, to a different power other than 2, you would use this, and it's called a caret. It's right above the division sign. So I'm gonna click that. It gives me a little box. That's where I'm gonna put my -2. And it gives me what? 0.25. Okay. The next one I'm going to type in is a -1. 2 to the power of -1, 0.5. And then 2 to the power of 0. Do you think it's going to give you 0? That would be my first guess. But no, anything raised to the power of 0 is 1. That is something that we're going to learn later on in the year. 2 to the power of 1, it's just 2. 2 to the power of 2, just in case, 4. Okay. All right. So first number is -2, 0.25. So I'm going to put it way down here somewhere. -1.5. So halfway in between 0 and 1. 0, 1. 1, 2. 2, 4. And what this one does is this one gives you an exponential function, which is the very last function that we're going to study in this class at the very end of the year. But yeah, it will give you half of a curve. Okay. Says, what do you notice about the general shape? We kind of already talked about it. One gives you a straight line. One gives you a U shape. I know mine looks like a V, but it's technically a U shape. And one gives you half of a curve. Are the following graphs functions? Yeah. Yeah, they're each going to pass the vertical line test. Each graph passes the vertical line test. So they want you to evaluate f of 2, g of 2, h of 2, only using the graphs. Well, we know how to do this based off what we learned yesterday. So f of 2, we know because it is an f, we have to go to this graph. So we go to the number 2, go straight up, find what point it gives us or what y value it gives us. So f of 2 gives us 4. Okay. G of 2 might give us something different. This is our G graph, also gives us 4. Cool. And the last one, H of 2. Let's go to the 2. Also gives us 4. Okay. Flip it over to the back. Graphing calculators can be useful tools when graphing functions. Fill in the table with some of the tips for graphing functions on the calculator. Well, I went ahead and filled it in for you just because I have certain rules compared to what they wanted us to write in. for graphing things on the calculator, okay? How do you enter a function into a calculator to view the graph? We talked about it with whenever we went over identifying functions. In order to put an equation into the calculator, put it into y equals hit graph, okay? How do you view the table of values for that function? Well, how do you go to the table? Let's say I'm going to put in a random equation, 2x plus 3, my favorite go-to. You hit graph to see the graph, right? Now, if you want to see a table of all the points that belong to this blue line, you are going to press second graph. Second is that blue button. Graph is right here. And there you go. You have your table, right? You can go up, you can go down to find the negative numbers and the positives. How do you change the portion of the graph to you can see on the screen, zoom in or zoom out? You can either use the window to type the parameters you want, and Zoom 6 resets the window. In this class, most of the time, we're just going to use Zoom. We're going to use zoom in, zoom out. Anytime you use these features, I'm going to try to zoom in out. I'm going to put the 3. Notice it doesn't automatically zoom out for you. You have to push enter and it'll zoom out. But you sit there and mess with it for a long time, you're going to find yourself a little lost. So Zoom 6 standard, that's your standard window. That's your regular 10 by 10 graph. And it goes back to, and it's reset basically. Goes back to the way it should be, right? Now it says use your calculator to graph each function below, draw a rough sketch of the function, and answer the questions that follow. And it looks like I had already included the graphs with them. So we're just going to continue practicing what we did yesterday and evaluate these numbers. So evaluate f of negative 10. Oh, we actually have to graph it on the calculator because negative 10 is way over here. Okay. So let's do that. We're going to go to y equals, clear that out, type in your equation. The equation is x plus 5. So I'm going to use x next to alpha plus 5. First thing I'm going to do is hit graph. Now, if we're looking for f of negative 10, that means we're trying to find where the x is negative 10. What if x is negative 10, what is my y value? So go to second graph. I'm up here at the negative 3, so I'm going to go up to the negative 10, and what do I see? A negative 5. Now it says list 3 ordered pairs on this graph. You can actually list any ordered pairs that you want. So I'm going to say 0, 5 is part of it, 2, 7, 5, 10. Really doesn't matter. Go back to y equals. Let's try the next one. Negative x squared. Okay. Second graph. This time they want us to find where x is the number 5. I'm still in the negative, so I have to scroll down until I get to the 5. And what does the y value give me? Negative 25. It says list 3 ordered pairs on the graph, any 3. 0, 0, 1, negative 1, negative 4, negative 16. Doesn't matter which ones. And for the last one, is going to be negative 1.5, now to the power of x. So if you're going to raise it to anything other than square it, you want to press that button right above division. Yes, you can put a little x there. And notice how it gives you that upside down curve, right? But they want us to find h of 0. So where we find the 0, we get a negative 1. 1, negative 1.5 is a point. 2, negative 2.25, and I'm out of space. Moving on. Number 4. Negative 0.5 x minus 3 point, not 3.6, 3.5. Let's look at the graph. Another straight line, and they want j of negative 10, which is 1.5. Okay, Next, I'm just going to ignore the list of three ordered pairs. 0.5 x squared plus 8. Hit the graph. Because of the squared, we're going to get that U shape, that parabola. And they want us to find n of 0. So where we have a 0, you can actually find it on paper right here, but 0, 4. And when I say on paper is because you know that the x is a 0, 0 is right here, you go straight up. That's the number 4. Okay. Last one. 0.5 to the power of x. Hit graph. They want us to find p of -4. Where we find the -4, our y value is 16. Okay. So hopefully that was nothing too difficult, just kind of a little bit of an extension of what you learned the day before with the last lesson. Okay. So it's just time for you to work on the practice.